The SANS Institute, the most trusted source for computer security certification training and research. Visit SANS.org to explore their full curriculum and latest training offerings. Onapsis is the leading provider of solutions to protect ERP systems from cyber attacks. Customers can secure their SAP and Oracle business-critical platforms from espionage, sabotage, and financial fraud risks. Visit them on the web at onapsis.com. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences Web Protection Platform. Signal Sciences, securing code and connecting teams. For more information, check them out at signalsciences.com/ESW. Welcome back, everyone, to Pulse Security Weekly. Just want to mention ITProTV's courses now include ITIL Managing the Lifecycle and Microsoft Hello for Business. Premium annual memberships include all video content as well as access to virtual labs and Q&A forums. Normally, you would pay $85.70 a month or $857 a year, but we have a special offer for our listeners. For a limited time only, get 50% off the monthly membership for the lifetime of your active subscription. You can use go to itpro.tv/Security Weekly. Is that what it is, guys? It's not in my teleprompter. I think it's ITProTV. itpro.tv.
If it's not, it will be.
itpro.tv/Security Weekly and use the code SW50. Thank you. So, Carlos.
Yeah.
You're going to talk about WMI stuff.
That's correct.
So when we say the basics of abusing WMI events, is this the logging or like management stuff using WMI?
Yeah, what I want to cover is something that we have been doing for a very long time, at least us attackers. Can you see the Word document?
I can see myself, which is creepy.
Okay, so it's not sharing my VM. Crap.
There it is.
There it is.
Oh, okay, so there it was. Okay. Cool. So WMI is Windows Management Instrumentation. We have covered this before. I would say at least once a year, one of us, Larry, myself, I remember Mick Douglas even covering this when he was at the podcast where we covered WMIC. And we have used WMIC to do queries against all of the Windows systems. We have used PowerShell to do queries against Windows systems. John Strand has covered abusing WMI via PowerShell in his webcasts. But there's one thing in WMI that is called events. Events is it is when something happens inside of WMI, we can take an action. So we receive an event, and then we can decide what we want to do. So we're looking for those events, something to happen. That is something that has been abused for many years. Typically, it tended to be abused by us geeks that tended to go very deep into Windows, and this is something that we have been abusing since Windows 2000. Sadly, APT 29 kind of brought it to the front side there. They start using it quite a bit. And then FireEye did a series of investigations on APT 29, and they did a series of white papers. And Matt Graver, that used to work for Flare at FireEye, now at Microsoft, and other engineers from the Flare team actually even wrote a very nice paper. And now WMI permanent events and temporary events are very well known by many practitioners out there. And very acting states are actually using this. So typically when we're looking at WMI, we work with three main types of events. We have intrinsic events. Intrinsic events is I'm looking at a resource inside of WMI, inside of my SIM repository, my database. I'm looking at classes. For example, everything inside of Windows is represented inside of the WMI database. In one way or another. I can do Win32_BIOS and I get the information about the BIOS. I can get instances of Win32_ processes, and each one of those instances corresponds to a process. I can do even the same for pieces of hardware, software. I can do it for even logical units inside of the OS, like it could be a user or a group inside of the OS itself. It could even be a network connection. WMI kind of provides all of that. That's why it's called Windows Management Instrumentation. So intrinsic events is when I monitor a resource, and it's represented by a class inside of that repository. Then I have what are called extrinsic events. Intrinsic events are actually when I'm monitoring something, not an instance like when a new process is created. I'm just looking internally into Windows, and WMI is just representing that object. For example, it would be the registry, which is the most typical ones that we see out there. And then there's another one that tends to be abused quite a bit, which is timer events. For example, we all know that if we enable scheduled tasks, it's going to generate an event log. We know that if we use the add command, it's going to generate an event log. Everybody knows that when you're doing DFIR, one of the first things that you go into the system is that you look for scheduled tasks. Hey, did somebody schedule a task on the target system? And they're using this for persistence. Well, with WMI, I can do timer events, and most people don't know where to look. Now, when we look at intrinsic events, as I mentioned, I have a very nice graph here. You have a query that's going against the SIM database, and it's looking, hey, tell me when something from this class is created, when it's been modified, or certain operation has happened against it. So in this case, I can actually be looking, hey, I want to a creation event on wing32_process. When this process starts, then I can take my action. So let's think of it as a malicious attacker. I have my payload, and I want to persist it on the system. What type of process do I want to see? Well, one of them would be probably the browser. If I see a new browser window being brought up, that means that it has network connectivity. So that means that I can launch my payload at that moment. So it won't happen immediately at boot up. It would happen when the user actually has a connection. I can say, hey, when a network card gets a DHCP address, and I'm looking at the Wing32 network adapter, and I'm looking for the property on DHCP, and I see that it actually got an IP address, then I'm going to take my action. Or I can look into the event log and say, hey, if I'm able to get at least 2 logon events, successful logon events, then execute my payload. What am I doing? I'm timing my payload so it is harder to detect. That way, let's say somebody's doing instant response and they boot up the machine, they log on for the first time, nothing's happening. They log off and then log on back again. Now my payload executed. So there's so many stuff that I can do just by watching the system, the different components of the system do different stuff. And the way we look at it is by creation, modification, or something happens to it. And I have here a very simple example of a query when I'm doing select asterisk from an instance creation event. Every 5 seconds check where the target is a process. So I'm checking for when a new process is created. And I can even say where the target instance, the name is Notepad, where the name is Chrome. I can check for those. I can even do it for process termination. So those are my intrinsic events. Now I have extrinsic. Now extrinsics, I am not doing a query against the database. I'm going against the resource. So I don't have to time it. Typically, when we're doing intrinsic events, I have to give it within a certain amount of time. So I have to do it every 5 seconds, every 10 seconds. And as a tip, never do it every 0 or 1 seconds. You're going to peg that CPU and you're going to get detected. So it tends to be a bit CPU intensive. So try to keep it 5 or above. With extrinsics, we're just going through a provider. We're going through a driver. We're going through a DLL, a library, and we're going straight to that resource when something happens. It could be hardware. It could be the kernel. It could be a library itself, checking specific components of the system. It could be the system. So in one, we're going through the SIM database, and we're querying the database. And another, we're going through direct interface to the device itself or what we want to query. Examples of this inside of Windows are going to be registry, routing table, and there's also the kernel. So typically when, for example, I want to look at the registry, I can check for registry key has changed. A registry 3 has changed. A registry value in specific has been changed. And then I'll have my trigger. I won't get the data on specifically what was changed or what was added or what was modified, but at the very least I can trigger when something specific changes. So here I have a very nice example, and it is when somebody installs a piece of software or uninstalls a piece of software, that means that HK local machine software, Microsoft Windows, current version, uninstall registry key is going to be modified. So I'm checking for registry tree change. Any piece of software is uninstalled or installed, I'm going to trigger my action. So this is very helpful for me in the terms that I can time my events. I can have a very persistent, how would you say, payload or backdoor install of the system that is not going to trigger always. So as people are doing insert response, they're looking at network traffic, this box can be my sleeper on my target. It's going to be my sleeper agent. The one that is only going to trigger, let's say, on a Patch Tuesday, or it's going to trigger when IT has their schedule of adding new software, or when the user downloads something and installs it. I'm going to muddy those waters in terms of actions. When DFIR comes in, the insert response team, the blue team comes in, and they're not looking at WMI because they don't know I can do this stuff in WMI. They're going to say, oh, he installed this piece of software. So this piece of software, when he installed it, is when we got the connection back and Bro or SourceFire trigger on this. No, it was because I had a WMI event looking for a modification of this registry key. I can do this same thing with the kernel trace provider.
So wait, hang on, Carl. So your payload doesn't have a heartbeat that calls back intermittently to tell you if it's there? You're just kind of like dropping it there, and you're not doing any kind of callback?
Exactly. I'm just waiting for something to happen to then trigger my payload.
Wow, that's evil. Okay, sorry.
Yeah. Don't worry. You can ask.
Time is on his side.
Yep, and that's why I like when I teach this in my class at DerbyCon, when I'm teaching PowerShell to students, I go like, hey, I can do this with VBA, WMI. I can do it via VBA. I can do it via COM objects. I can do it via C++. I can do it via .NET binaries. I can do it via Python if I want to. I can do it via Ruby. Ruby has WMI libraries. So I can do it. WMI. I can access it 10 ways to Sunday. There are just so many ways I can interact with WMI. But it's a very open API inside of Microsoft. For this, I'm just using PowerShell as my example. So as I was mentioning, I can do, if I don't want to trigger checking every 5 seconds, I can just, for a process, I can actually just use kernel trace, and I can execute exactly when a process starts or when a process stops, or if I even want to be even more evil, I can say when a specific DLL is loaded on the system. So I'm just checking win32_module load trace. And here I have an example where the file name is system.management.automation. And then I have the kind of like the wildcard, which is the percentage in WQL for DLL. So when am I triggering on? PowerShell. Anytime PowerShell is executed in this system via ISC, via PowerShell.exe, via whatever method, this is going to trigger. Now,
Carlos, does your code, whatever you've written, it didn't have to run in the background somewhere, or like where does your code run?
I'm going to get to that. It's actually going to be stored in a database inside of the system, inside a binary file, and Microsoft is the one who's going to trigger on it.
So the operating system triggers a WMI event and executes your malicious payload based on an event. That's really evil.
Yeah, and in this case,
like what you think.
If I want to be a blue teamer and I want to use this for good, this would be a very good one, the Win32 module load trace. So I can actually take an action when PowerShell is loaded. All of a sudden I'm saying, hey, PowerShell was loaded, and I can save my own event, or I can check for specific DLLs for libraries, and have kind of like a chain of, hey, when this is loaded, and also this, do this. So I can check for specific TTPs of a payload. I can actually use WMI as my own hips inside of the system.
Right. So it can be used for good and evil.
Correct. I do cover several examples in class. I cover, this is how you attack, this is how you defend. This is how you attack, this is how you defend. And then at the end, I go like, oh, and if you want to really mess up defenders' heads, this is how you modify their own queries and get into their heads. So I cover all of that stuff in class. So I'm just trying to cover at least 4 or 5 hours of class into half an hour. But I'm planning on doing this as a series. So this is the first one where I'm kind of going at a very high level, and then we'll go into details in other podcasts where I'll do a second or third part of this. So when we look at instance events, one of the ones I like to look is win32_local time. So this means that I can actually trigger on a specific date, on a specific day, where I can say, hey, trigger on every second Wednesday of every month, or trigger only on Thursdays every week. And I can have kind of like my own scheduled task. And the way it happens is that I actually build a query that goes into the SimDB, and I'm actually querying Win32 local time, and I'm telling it, hey, give me seconds, days, day of month, and I can actually build my own query here. So this is very useful. Like, in this example, here I have a query that will execute every 30 seconds. So every 30 seconds, this is going to execute whatever action I tell it. So as you can see, here we have an example. I have a query that goes to the database. I'm checking a specific class, and if it matches what I want, then I do my action. Now, I mentioned temporary events, and I mentioned permanent events. Right now, for this specific technical segment, I'm going to cover permanent. Why permanent? Because it's the one that typically you're going to use more when you're starting out with events, because this is the one that you're going to set in the machine. It's going to be there. It's going to survive reboots. They're going to restart that machine, and it's always going to be there. Now, the way that permanent events happen is that I'm going to create an instance of a filter and then a consumer. The filter is a WQL query that looks for that event that we cover, an extrinsic or intrinsic one. Then we create a consumer. Consumer is the action that we're going to trigger. And then I'm going to have a binder. A binder is what's going to unify my filter and consumer together. And what happens when a permanent event is that permanent event actually gets saved into a database, which is the SIM database, which is the objects.data file. And almost all AV vendors until last year completely ignored objects.data, because if they killed objects.data, they killed Windows. Windows depends on this database to run. But sadly, since Matt Graver and FireEye did their white paper, it kind of got a bit more attention on this very old technique. And now we're starting to see at least Microsoft starting to add event logs for when you create permanent events. But still, most defenders out there, if they cannot even trigger on the most basic events of a scheduled task, at least your medium level, maturity level blue team doesn't still know about this. And one of the advantages that it's run as system, and it's run under the WMI PRV-SC.exe. So this X is actually going to run this. And you're going to say, oh, but Carlos, that means that I can take a deeper look into it. Well, yes. And that's why I'm doing it. I'm doing kind of like blue on a purple kind of technical segment here. It's not everything red. So here I'm giving you what you should be looking for. You see something that spawns out of WMI PRV-SC.exe, and it is CMD.exe, it is CSScript.exe, it's PowerShell.exe. Something weird's happening here. So you should be looking into that. WMI PRV-SC.exe should not be triggering any of that stuff unless you're running Dell systems. Dell has a very I don't know, bad habit or something of creating a bunch of permanent events for their updates or for the drivers and BIOS and other stuff. And a word of advice, if you're a pen tester and you want to go under the radar, most people actually set up rules like, hey, we have this permanent event that has this name. It's from Dell. Ignore that. Don't trigger on it. Well, you can modify those. You can actually change the query and you can change the action. You can change the consumer. Now, on permanent events, when we look at the consumers, we're kind of a bit limited on what we can run. We can either use an active script event consumer. The active script event consumer will run VBScript or JScript. Now, if you have been following in Twitter Sub-T, Casey Smith, you know that he uses in so many ways JScript and VBScript and abuses systems in ways that it makes a Microsoft engineer cry. He has so many techniques of bypassing device guard, app locker, carbon black, and many times what he's actually abusing is binaries in the system. And JScript, and he likes using JScript in many ways with regsrv32, with CS script, WSA script. He uses all of those binaries.
Carlos, what is JScript?
JScript is kind of like Microsoft versions of JavaScript, but for system administration.
So it runs natively on all Windows systems?
Yes.
Okay.
And then you have the command line event consumer, where the name kind of says it all. It will actually execute a command on the system. So you can actually execute regsrv32. You can execute, if you want, PowerShell.exe. Now, with the active script event consumer versus command line, you're going like, well, Carlos, why am I going to call C script with command line if I have active script event? And the best reason is active script event, you save the script itself into the database in your SIM database. So it's not on disk, it's always on memory. So typically, a lot of people poo-poo VBScript or JScript or Windows scripting host. Well, here's one of the reasons that you have to learn it. Because if you learn it very well, you can actually abuse it quite a bit with active script event consumer because everything stays in memory. And it's saved into a binary file that all AVs ignore completely. And those that do look into it, you can obfuscate that JavaScript, that JScript or script enough.
JavaScript, like 100 plus different ways you can obfuscate it.
Yep, and there are actually tools out there that will do it for you.
Right.
And another one that you can use, another consumer is log file event consumer. This would be used if you want to actually write to a log file. And I remember covering this in class, and I said, I don't see a scenario where this could be abused. And a student quickly mentioned, well, the configuration file for Java on a system is actually a text file. And the configuration of many extensions out there and programs are actually text files. So you can actually, you can create something that will backdoor the system. When your query matches, it will create a backdoor and go like, that is interesting. And
it's really scary. I think the if you want to be a really good penetration tester and you've got that hacker mindset, first of all, and then you start learning all of these intricacies in Windows, that's just frightening. It's frightening to me, Carlos, because as most of us well know, the level of defense in most Active Directory and Windows environments is pretty weak, especially when you talk about some of these advanced techniques that you're covering right now.
Oh, yeah. And my favorite part is that you'll see the sysadmin knows about this, and then you go to the IR team or you go to the security team, and they're completely clueless.
Yep.
And that's one of the reasons we are always stressing to people, take your time, take 3, 4, 5 years and just go into IT work where you need to administer systems, automate stuff, because that is when you're going to learn all of this stuff, all of the ins and outs of the system.
Yeah, and I definitely focus on Linux and Unix, but certainly if pen testing was my job today, I would be taking as many courses and learning as much about Windows and Active Directory and all the scripting languages and things like that today. I think that's more important probably than ever before, Carlos, right? I mean, Because, like, I don't know, even like 5 or 10 years ago, like, you can kind of get by. Like, I think today, to really be effective, you have to know a lot more about Windows. And it's been extended a lot. Like, PowerShell didn't exist, 10, 15 years ago, right?
Yep. It came out. It came out in the XP time.
Yep.
But the thing is that it wasn't included with the OS until Windows 7 and 2008 R2.
Yeah. So there's been a lot of advances lately that I think you really got to up your game.
Yeah, and what we're seeing, a lot of people are not, like we were talking before, a lot of people are running stuff in the cloud, and now you have to automate all of these workflows in the cloud. Mm-hmm. So if you have stuff in Azure or AWS, you need to script it. You need to code against your local boxes, your VMs out there. You need to interact with APIs. So right now, organizations are requiring less administrators, but they're requiring more skilled ones that know how to do, and I know that it sounds kind of cliche, that know how to do DevOps, that have that development and operations mixture and mindset.
And this is a trend that's going to continue. I was talking to a vendor that is providing protections for Office 365, and I was asking them questions like, so like, how much is Microsoft pushing people in this direction, and how many organizations are still like ready to go there? And Carlos, I don't know if you know the numbers. I don't remember them exactly, but the majority of organizations have to make this transition, and Microsoft is really pushing people towards that transition. And to make that switch requires a lot of the skills that you're talking about, Carlos.
Oh yeah, but right now you have Azure, and when you look at Azure, how do you automate Azure? You automate Azure with runbooks. And what do you run mainly all of those runbooks? Well, you write them in PowerShell. Mm-hmm. AWS has PowerShell modules for their stuff. They have Python libraries for their stuff. They have Ruby libraries to automate their workflows in the cloud. Same thing for Google and their cloud initiative. So it is no longer like you are a VMware admin and you know how to spin up a couple of VMs and have templates and sysprep stuff. Now you also need, we need on demand, we need 50 servers. How do you deploy it? Well, you're going to have to roll up your sleeves and you're going to have to script it. And
so that's interesting, Carlos. So it almost sounds like to be in IT as an administrator and or be in security as well, like you're going to know programming, I think, more than ever before.
That's correct. Mm. You need to have and specifically the logic, because as you're moving from language to language, if you have the proper logic, you only need to learn the syntax of each language to be able to use it. And that's why many times we see students go into a college and they learn Java and everything's Java, and then you tell them use Python and they're lost because because
it's not object oriented, right? So it's a different kind of logic.
The professor decided to teach them a language and not a logic, how to think like a real computer.
Right.
I've seen people even not take algorithms as not part of their scheduled classes.
Right. Well, and if Doug was here too, Doug and I would get in our rant about teaching engineering and programming and algorithms and logic in elementary school, and like way before college too. Like way before college, I think when you reach that age of 7, 8, 9 years old, you got to start learning programming. And I hope that's the direction we start going in, because what we're discovering today with Carlos's tech segment is you got to know all this stuff.
Mm-hmm. Oh yeah. And just to continue with the segment, another one we have is scripting standard consumer settings, where we can just set up additional settings to my consumer. Another one is SMTP, event consumer, where I actually send out an email. Sadly, it will not let you use HTTPS. It's just plain SMTP, no SMTPS. No IMAP, no POP3, only plain vanilla SMTP without credentials. So sadly, inside of a network, we won't be finding this much. Unless you set up your own SMTP server and relay out there somewhere in the world, but the chances of somebody else discovering it are going to be high. And also, you cannot control even the port number, so you cannot obfuscate the port number into a higher number. So you're going to have to be a port 25. So it's not that useful. So
how much you got left, Carlos? Because my production staff is telling us to wrap it up.
Okay, so let's go here into an example. For this, what I'm going to do is I'm going to create a filter here for to abuse when you plug in a USB drive. So what we're actually going to be doing is I'm going to select from instance creation event every 2 seconds when a new class or a new object is created inside of the WMI database, and it is of win32_volume. So that means a new drive has been added. And I'm checking for the drive type, which is going to be 2. 2 is removable. So here I have this filter here, and I'm going to send it over to root cmv2 under descriptions. I'm going to create this object here. In fact, it's all the way here. And you can do the same here with, let's say, why did it fail? Oh, I'm not running as administrator. Sorry about that.
That's good. That's good practice.
Oh, yeah. You should, this is one of the problems with permanent events. You need to be admin to be able to do this. But thankfully, next time I'm going to cover how to do temporary ones. And for temporary ones, they run inside of a process, and the process will execute with the privileges of the user. And as long as the user doesn't reboot his machine, you can actually take actions. I've been doing quite a bit of work with Active Directory, and I'm seeing so many people just suspend their machines. I'm looking at the last time they have logged on, let's say with Macs, and I've seen people keep their Mac without logging off, logging on for months. So let's go here. Let me create my query first. So this is what I'm going to be looking for, which is a drive being inserted into the system. Now what I'm going to do is I'm going to create my consumer, and this is a command line event consumer. And I'm going to give it a executable path, cmd.exe. I'm going to give it a command line template. What am I going to execute? cmd.exe, echo hello. And then whatever is that new drive on the letter, I'm going to save it as test.txt. So I'm going to save a test.txt into that USB drive. Let's run this, and let's create it now in the database itself. It's safe inside of the database. Now what I'm going to do is I mentioned I'm going to create a binder. The binder itself is going to join both my query and my action together. So let me execute my binder. And just in case, all of this stuff is already automated in PowerSploit. It's already automated inside of the Empire framework of tools. So I'm just going to the nitty-gritty, but you can actually use those tools to do the same. They allow you to do permanent events. So
basically, say copy a file to every removable volume that's inserted into a Windows system.
Exact. And in this case, it's just test.txt. If I want to be really evil, what would I have done? Well, I would have created an active script consumer. I would have base 64 encoded a binary, put it inside of my script. Then what I would have done is just written that executable over to the drive. I would have then go into the settings of the file, or the properties of the file. I would have changed it into hidden, and then I would have put an autoruns.ini, and I would have changed that also to be hidden. And now I have a small payload there. Or I could actually write another script that takes data, an encrypted piece of data that probably I saved somewhere in the drive, and every time a new drive is inserted, check if the date on the file in there matches my file. If not, then I'll write a new file into it, and that way I can use it for exfiltration. So there are many ways that I can actually use this. So right now on this system, I don't have anything connected to it. So let me plug in a USB drive here. Let me find my USB port. Here I have a new drive. It's inserted, drive E. Let's go computer. Let's go to drive E. And now I have here my file test.exe. Now one thing I can actually do just to show that it works is I can just delete this. Remove the drive, reinsert the drive back on my machine. There we go. I didn't unmount it in drive. Open view files. And then again, here's my test.exe.
That's awesome.
And that's what we're going to, as far as we're going to go today due to time. Next time, we're going to talk about temporary events. After that, we're going to talk about detecting all of this stuff. And then probably on a third or fourth one, we'll go into a bit more advanced stuff on how to use support evil.
Carlos, thank you very much. We're going to take a short break, come back, and talk about our stories for the week. Stay tuned. Don't go anywhere.